Welcome to the class on the construction of canonical LR parser. Let me introduce myself. My name is Tinku, Soman, Assistant Professor, Computer Science and Engineering Department, MBITS. Let us start our class. As we all know, canonical LR parser comes under the category of LR parsers. Basically, LR parsers are classified into four types. They are LR0, SLR, LALR and canonical LR or CLR. When we look into the canonical LR1 parser and LALR1 parser, we need to identify LR1 items for the construction of the parser table. So what is LR1 item? LR1 item means it is a combination of LR0 item plus the lookahead. So what is LR0 item? We already discussed what is LR0 item in our previous classes, and we need to study about what is a lookahead, how we are going to identify a lookahead corresponding to each of the production. Consider an example. This is the grammar given. Based upon this grammar, we need to identify the canonical LR parser table. So basically the first step for identification of the parse table is we need to add the augmented production onto the given grammar. So the augmented production given is S dash gives S. So that is the augmented production given. Into that augmented production, we need to then apply the closure for identification of the LR0 items. So how the LR0 items are identified? LR0 items are identified by putting a dot symbol. So for the augmented grammar, we are putting the dot in the beginning of the starting symbol S. So if you are putting dot at the beginning of the starting symbol, then all the productions which is starting from this dot S will be comes as the closure property. Then we need to identify the lookahead in the canonical LR parser. So what is the lookahead of the augmented production? Basically, or by default condition, the lookahead for the augmented grammar or augmented production is the dollar symbol. So according to the closure property, S can be written as dot AA. So how the dot AA comes? Because of the closure property or the dot we put at the beginning of S. Next, we need to identify the lookahead corresponding to the production S gives dot AA. So how we are going to identify the lookahead? In order to make the lookahead, I will give you an example. So consider a production. A gives alpha dot B beta. That is a production. And the lookahead corresponding to that production is A or B. That means the terminal symbol A or B. Then, according to the closure property of dot B in the first production, B production can be written it as B gives dot gamma. And we need to identify the lookahead corresponding to that production. Here it is given as C or D. How we identify the lookahead of the production B is C or D. In order to identify the lookahead, what we need to do is we need to identify the first function for the symbol that comes second after to the dot operation. That means in the given grammar, beta is the second symbol that comes after dot. So what we need to do is we need to identify first of beta. And for suppose the first of beta here is C or D. That is why we written it as the lookahead for the production B gives dot gamma as C or D. Consider another example. The example is A gives alpha dot B and the lookahead is A or B. Because of the closure property of dot B, we can write the production B as dot gamma. Then how the lookahead A and B comes as the lookahead for B? how it will comes. According to the basic rule of identification of the lookahead, it will be the first function of second symbol from where the closure property is applied. That means B gives dot gamma comes from this dot B. So according to the closure property of dot B here, we can write it as B gives dot gamma. So what is the second symbol that comes after B? The second symbol comes after B is either A or B. So what is first of A? First of A is A itself because it is a terminal symbol. What is first of B? First of B is the same symbol which is the terminal symbol. So we can write it as lookahead A or B corresponding to the production A gives dot gamma. So this is the grammar. S dash gives dot S is the augmented production. And by default we are putting it as dollar as the lookahead. Because of this dollar dot S, we have to write S as dot AA according to the closure property. And how this dollar comes? This is the lookahead. How the lookahead will be identified? Lookahead will be identified by looking at the first function of the symbol that comes after this dot S, or the second symbol that comes after dot. So what is the second symbol that comes after dot? That is the dollar. So what is first of dollar? First of dollar is dollar itself. So we are going to discuss about the more details. So this is the grammar. S gives AA, A gives AA or B. So initially we added an augmented production. S dash gives S, and for identification of the LR0 item we put a dot here, dot at the beginning, and by default dollar is the lookahead. So since this dot S comes, according to the closure property, S can be written as dot AA. According to the closure property of dot A can be written as dot AA and A can be written as dot B. Then we already discussed how this dollar comes. How this dollar comes? Because it is the first of this dollar. So first of this dollar is dollar itself. We need to identify the lookahead for the productions of A, both these productions of A. So what is the lookahead here? In order to identify the lookahead, from where this production comes, this production comes according to the closure property of this dot AA. So what we need to do is, in order to identify the lookahead here, we need to identify the first of the second symbol after this dot, or we need to identify the first of the symbol that comes after this dot A. So what is first of that symbol? That is first of A. What is first of A? According to this grammar, first of A is small a and small b. So for these two productions, the lookahead will be A or B. I think it is understood. Once again I will tell how this A and B comes. It is based upon by looking at the lookahead corresponding to this part. So that means we need to identify the first of A which comes after the second symbol for this dot. So first of A is AA and we written as A or B. So ultimately we are getting the state I0. I0 contains the following productions and the corresponding lookaheads. What is the next step? We need to perform the goto operation. So goto operation will be performed on the symbols from the state I0. So first of all we are looking at the symbol S, which is a non-terminal symbol. So if you are performing the goto operation on S, we will get S dash gives S dot. Then we are putting it as dollar as the lookahead. How the dollar comes? If we are performing a go-to operation, then whatever be the look ahead at the previous state will be same as the look ahead in our new state. This is only for the go-to operation. So this is the go-to operation for symbol S, and we are getting S dash gives S dot. Then how this dollar comes? Dollar comes is based upon this dollar. And since there is no other symbols after dot, there is no need to perform the closure operation. So that is an end state production. Next one, we are going to perform the goto of A. So what is goto of A? We will get S gives A dot A, because this dot is put to the next space or after the A. So we are getting S gives A dot A. And how this dollar comes? This dollar comes because since we are doing a go-to closure property, whatever be the look ahead in our previous state will be same as in our new state. So this dollar will be same as this dollar. Then according to the closure property of dot A, since it is dot A, we need to expand A, or we can write it as A gives dot AA and A gives dot B. Then how this look ahead comes? How this look ahead comes? What is the general rule? The general rule is we need to identify the first of the second symbol that comes after dot. So what is the first of the symbol? First of symbol is first of the second symbol. What is first of the first symbol is this one, second symbol. What is first of dollar? First of dollar is dollar itself. So we are putting dollar here and the dollar here. And similarly, we need to identify the rest of the states. So when we consider the go-to closure for small a, for the terminal A, what we will get? We are putting this dot from here to here. So we can write A gives A dot A. And how this A or B look ahead comes? Because it is same as this A or A. Sorry, A or B. Since we are putting a dot here, we need to perform the closure. So what is the closure? We need to expand A. While expanding A, we will get A gives dot AA and A gives dot B. Then how the look aheads will be identified? We need to follow the principle of look ahead. So what is the principle of look ahead? The principle of look ahead is identify the first symbol after this dot A. So what is the first symbol after dot A? It can be either A or B. So we can get the look ahead as A or B. Here A or B. Then if you are performing B, if you are performing the goto of B, we will get A gives B dot. And this A or B, look ahead A or B will be same as this A or B. And why? Because is that we are performing a goto operation. So if you are performing a goto operation, the look ahead will be same as the previous state, and the look ahead will vary if you are performing the closure property. And similarly, from the I2 state I1, there is no other symbol to process. So this is an end state production. I2 is not an end state production. So we have to perform the goto operation on A, small letter A and B. And the state I3, we need to perform A, small a, because we are getting the same state. That's why we are making it as a loop. And for B, it will be the same. And similarly, we need to identify each of the states, and we get a total of 10 states, number from 0 to 9. So another thing we need to remember is that, or we need to focus is that, when we look into state I3 and I6, we are getting the same LR0 item. Here the LR0 items are same, here the LR0 items are same. Only the look ahead will be different. So these will be considered as two different states. And similarly, I4 and which one? I4 and I7. When we look into I4 and I7, LR0 items are same, but the lookaheads are different. Here it is dollar, here it is A or B. Another one is I8 and I9. Lookaheads are same, AA dot. Here it is AA dot, here it is AA dot. Only the lookaheads are different. So this is one thing we need to focus. So based upon these different time states, we are going to construct the LR parse table. So when we are looking into the construction of LR parse table, there will be two different sections. One is the go-to part and the second one is the action part. In the action part, we are writing the 4 different actions: shift action, reduce action, then accept, and the last one is here. And the rows in the parse table will be the different states. It will be numbered from 0 to 1. So this is the table we are getting. This is 0, 1, 2, 3 up to 9, and the action table and the go-to table. So the basic difference between the canonical LR parser and the SLR parser is that only for the lookahead symbol we are putting the reduction operation. So what it means? The reduction operations are basically given to the end state production. So which are the end state production here? The end state production here are, one is I1, then I4, then next one is I5, I7, I8 and I9. These are the end state productions. And in these various end state productions, this is an augmented, I1 is an augmented production. So we have to do the accept operation if dollar comes. That means if dollar is the input symbol, then we need to accept the grammar. That is the meaning. So when we look into I4, when we look into I4, the two lookaheads are A or B. So that means this reduction according to this production will only happen if the inputs are either A or B. That means for the state I4, if A and B comes, if A or B comes, then only we have to do the reduction, that is R3. So what is R3? This is R1, this is R2 and this is R3. So R3 is the reduction we need to perform. When we look into state I5, dollar is the lookahead symbol. So what it means is that only when dollar comes, then only we need to perform the reduction. So only when dollar comes, we need to perform the reduction. Here it is R1. And for I7, here the lookahead is dollar. So only when dollar comes, we need to perform the reduction. When we look into I8, the lookaheads are either A or B. So at either A or B, only we need to perform this reduction. Then when we look into I9, the only lookahead symbol is dollar. So only when dollar comes, this reduction will perform. This is what the canonical LR parser. So only when the lookahead symbol comes at the input buffer, then only we need to perform the reduction. For all other symbols, it will be considered as an error. So this is all about canonical LR parser. Thank you for attending this session. Thank you once again.